Hey folks, welcome to this developer coaching webinar. We're so stoked that you're with us today to discuss boosting developer productivity with Oracle Autonomous DB and generative AI with Derek and Steve from Oracle. My name is Aaron. I'm also with Oracle. We're really stoked about this webinar today. But before we get to it, let's do some housekeeping pretty quickly. So during the webinar, you might have some questions about the demo. You can ask questions in real time. We have a bunch of folks on this side of the house able to tackle your questions in real time as Derek and Stephen are demoing. So, and with that, and actually, you know what? And if we have questions that aren't able to be answered during the webinar, we'll carve out some time at the end of the webinar in which Derek and Stephen will field your questions. So, with that, without any further ado, I will turn it over to Derek. Are you up first?
I am. Thanks, Aaron.
You got it.
Hello, everyone. Welcome to our presentation today on AI services. Joining me today is Stephen Nichols and Pete Madura. All of us are on the Code Innovate team. Today, we're going to cover four topics: Select AI, vector search, Select AI with RAG, and introduction to generative AI agents. I'll be covering the first two. Steve will cover the other two, and Pete will cover the Code Innovate program overview. Back in February last year, we actually covered Select AI. So this is a bit of a review. I'll be skipping by a fair bit of material to be able to fit all of it in today. I will focus on lessons learned. We've been working with customers for the past year and a lot of the interest around Select AI. We've been doing Code Innovate, so we'll be sharing lessons learned there. Also, vector search. We did a vector search presentation in August last year. We've done a lot of updates to our demonstration material features baked into the service. I'm going to share with you that. So there's quite a bit of new content around the vector search part. So let's get on to it. Select AI is really a conversational interface to access data in your database, in your relational Oracle database. Allows users to interact with the data without having to know SQL. It's not just about accessing that data, it's about content generation. You can create email programs, recommendations, sentiment analysis. You can ask it to summarize document content. So it's really giving you that conversational interface between data that's in relational tables and data that you're looking for and searching for, but you don't need to or want to use SQL. Uses the database security model, leverages all of the good features of the database, and allows you to use different language models. You can use the language model of your choice. We can access and use different language models. As I said, the initial presentation we did way back in February used an OpenAI service. That OpenAI service is very good at generating SQL, but it also meant that customers needed to share their data outside of OCI, and that was an issue. Customers are sensitive about their private data. And so there was a little bit of hesitation to do that. Today, I'm happy to say that we've had now for a little while our Metalama models. They do a very good job of generating SQL. It's all contained within OCI. There's no concerns about exposing your data outside the internet. We've had, again, very number of POCs and Code Innovates with customers using the Metalama model, and it works great. If you choose to use other models, though, they're available: Azure, Cohere, Google. It's a very fluid situation. These models are coming out, as you probably already know. There's new ones coming out all the time. You can use the model of your choice. Select AI provides a number of options when you run Select AI. The default is to run SQL. You can show the SQL, see what it looks like, explain the SQL. Narrate gives you a conversational interface with the data, and then chat. Chat is unique. The questions you pose through the chat interface don't go to your data, they go out to the internet, and we'll show you that. This is a typical SQL query generation pipeline. You take data that's about your metadata about your data. That's table names, view names, column names, data types, comments on those tables and columns. Then you have a question. I have a question about this data. Send that, the metadata together with the prompt to your language model. The language model looks at your question. It looks at your table names, your comments on the tables, formulates a query, sends that back to you, and optionally you execute that query. And so it's really bypassing the whole need to create and write SQL or use a BI tool. The key enabler for this is a profile. A profile encapsulates specification of the provider. In this case, we're using OCI. We have a credential. We have a model. I'm using this same one, the Metalama 305 billion instruct model. I'm using that one today, and then specifies the tables and or views that you'll be wanting to pass through to your language model to enable it to generate the query. You have to enable that profile as well. You can have different profiles for different domains. We have maybe an AP one, an AR one, a different profile for each domain. And then in an application, say for like Apex, you can let the user select that. What question do you want and who do you want to address it to? So let me switch back to kind of the code end of things. This is a bit of a code review exercise. I'm not going to execute all of this. Steve and I like to produce content that is technical, that gives you the nitty gritty and how to actually make this work in your environment. We tend to stay out of the slides. We dive into the details. Steve has created Git repositories for all this code. So don't feel like you have to like write this stuff down. All of this is going to be shared in the recording through Git repository links with code that you can execute in your environment. So let's get started. First things first, create a credential, grant access to DBMS Cloud AI to MovieStream. MovieStream's the owner of the data. We've got a credential here. If I scroll down, we've got a profile. If one exists, you drop it, create a new profile. There it is there. Comments equals true. There's some specifications that you'll want to put in there. Use conversation, use comments in conversation. Then you'll set the profile, and there the get profile allows you to find out which one is currently active. Now, when we started working with customers, it's very iterative. You issue some you issue some prompts to the database, you get back results, you go, oh, the service is confused about something. We need to add some comments to explain more about the data. Every time you make a metadata change, add a comment to your tables, you actually have to refresh the profile. So what we realized is, well, let's just create a procedure to do that. Let's just set the profile in the procedure, and it's very quick. You can iterate through updates. So I'll execute this now. Again, the procedure is in the Git repository, so you don't have to worry about writing that down. And let's get into running stuff. So you have this interface. You say, select AI, what movies are Tom Hanks in? If you have not set this profile, the first thing it's going to do is go, where's the from clause? Once the profile is active, it knows to use the profile, and then you're good to go. There's a number of, this is by default, a run mode, like run the question, like pose the question, generate the SQL, run the SQL. You can see how that works right there. If you want to see what it's actually generating, you use the show SQL. Select AI, show SQL, there's the SQL. The narrate is a little bit different. As I said, it's a conversational interface. If I had said, select AI, how many customers exist, it would just say 148, 129. If I say, select AI narrate, it says, there are 148, 129 customers in total. So customers have found they prefer that. We have this exposed in an Apex application. They have preferred to use the narrate function. Of course, you can change that in the Apex app, but this is the preference. Now, exactly the same question. Let's use the chat interface. Remember, I said that it's now not asking your data, it's going out to the internet to get that data. And so you can see it's like, oh, how many customers in the world are there? And so then it goes through and goes through what it learned from it when it trained. And this gives you an idea that you can ask questions inside your organization using narrate and outside using chat. If you want the SQL explained, there's an example there. It really just explains what the SQL is doing for veterans like me. It's like, yeah, I already know what the SQL is doing, but if you have lay people, might be helpful. You can't nest the SQL. You can't say select star from select AI. It's going to say from anytime you do that, it's going to say from keyword not found where expected. So this using select AI is really helpful for testing, for running it in SQL Developer or running it in VS Code like I am. But practically speaking, you're going to use in an application DBMS AI generate. And then you can take the result of this SQL and insert it into a table and then execute it at some later fashion or just look at it, save it. If you want to save the result or combine it with anything else, you're going to use probably DBMS Cloud AI Generate. And there's that other question that I initially did with the run SQL. You see the conversational interface, blah, blah, blah. You can see that results. Let's get into the lessons learned. Avoid having data values as the same column values. You might think that's kind of odd. It is odd, and it was unusual. I'm just passing on something we learned. We had a column called region, and the data values were region, state, and so it got confused. So just a kind of heads up, hey, if you got a column, make sure your data isn't the same as the column name. Deal with case. That's really important. Make all data a particular case and specify that in the table comments that the data is that case. Use comments to allow partial matches. If you are looking for a partial match string, you need to tell it. Otherwise, it's going to use the equals. And so you just need a comment on your table to specify that. Alias is something else. If you have an amount column and the amount is revenue or sales or income or something like that, or it's being known as other values, tell it. Go put a comment on the table that said, hey, this may also be referred to as revenue when the user asks the question. It's effective. It's really effective. We also had to strip out special characters. We had double quotes in there. We had to get rid of those in the text. So you might need to do that. And bear in mind, changing comments requires a refresh of the profile due to caching. So again, we created a procedure. Just every time they make changes, you've got to do a refresh. If you're using OAC, you do have the AI assistant built into OAC, and it uses a language model, but it only looks at AI or OAC data sets. So anything outside OAC, it's not going to know anything about. And so you could consider using AI assistant, but if you're using this in an Apex app or against other data, you'll of course want to use the Select AI service itself, and you might use both. So let's go back in. I'm going to clear my comments out to illustrate something. So to set and clear your comments, you just set it to a double quote. And now let's just look at this. Select AI, show all movies produced by Universal Pictures. So if I execute that, it actually comes up with nothing. Why is that? Well, studios in this column, there are multiple studios. It happens to be a JSON string, but that's beside the point. The fact is, if you have multiple values and you're searching for a value within other values, you do need to tell it that. And so how do we fix this? We go in here whoops. We go in here and we say comment on columns movie.studio. All data is mixed case and queries should return partial matches. For example, and examples to give to the language model are good. They are effective. For example, if the user requests movies produced by Universal Studios, you should search for percentage Universal Studios. Let's see this in action. I've changed the comment. Now I'm going to go in here. Let's actually run this again. And now let's look at the sequel. What is it going to do? We already saw the initial sequel. It's studio equal Universal Studios. There it is there. My comment now allowed the language model to realize, hey, I need to deal with case. I'm going to do upper studio like Universal Pictures. And then you get results that are pretty effective, pretty reliable. And then you go through, if you want to start testing out Select AI, it's going to go through this iterative process of basically augmenting your table definitions with comments. Now, something else to consider, we have lots of dates in our data. And so I told it, hey, movies.year is the year produced. Do not use it for aggregating any movie stream calculations. Don't do that. Streams.dayid. Use this date to establish various metrics by year, month, day, etc. for movies that are streamed. That's a directive to the language model. That is passed to it. Now, when you do that, select AI. What is the box office trend by year? Now we're getting into analytics. It does a pretty darn good job of generating SQL using anything like ranking functions, aggregating functions, trending, date extraction. So what select AI, what are the top 10 performing movies in terms of sales between January and March 2026? That's fairly specific. It's going to require a ranking function, but also an extraction of the months out of the day date column. It knew to use day ID between 1 and 3, group by title, fetch first 10 rows only. We've worked with customers, and I've been really impressed with the ability of Select AI to come up with some fairly complicated analytics SQL. Here's another one. Compare movies that have box office sales below the overall average. Well, it's got to do a subquery to capture the overall average and then compare it at the line level. So it's pretty impressive. Now let's see what this looks like in an application. I'm going to use this query here, copy. Let's go to, whoops. Let's bring up Apex. And we'll log into Apex. We'll use movie stream. And I've got a couple of applications in here. We've got a base one that we use often for demos, and I've got another one that we modified for a customer based on some things they wanted to add to it. So the first thing to note here is this one exposes the ask your database versus not. If I ask this question now as is, it'll use a chat interface. Don't want a chat interface. I want to ask the database, so I'm going to do that. And I'm going to issue the prompt. This is a very basic application. The important thing to note is Apex is a tremendously popular application environment that allows you to customize this any way you want. And so when we went in with the customer, we started with this, and then we just modified it to suit their needs. You can set the language model in the AI settings upper right. And so imagine you can have multiple, quote, sort of subject areas. Each is a profile, and have the user pick them and ask questions of different areas. There's a very basic interface. Let me go back and let me go to the other one that I wanted to show you that's slightly different. And this one, they wanted to give a feedback. They said, hey, how do we know it's working? Well, I want to allow the user to basically get a feedback. And so let's do that. We'll go in here. We'll ask the same question. And they also wanted to change it from a run SQL to a narrate SQL interface. We did that. Everything's modifiable in Apex. So now we're asking that same question. It's giving now that conversational response, it even adding additional information on top of the straight answer to your question. And then with the feedback, it's, hey, was this effective or wasn't it? And allows the user to kind of write that back to the database. Then developers can go here and go, huh, this was helpful, this wasn't. And so you've got these positive, negative type responses that allow the user to kind of give feedback on Select AI. So super helpful, very easy to get going. I would encourage people to explore Select AI. We have a lot of customer interest in that feature. Now let me switch over to vector search. Vector search is one where we've made a lot of updates to our demo content. I want to show you that. Now Select AI is querying across your structured data, across multiple tables, multiple columns. This vector search is more suited to querying large amounts of data within a text, such as a clob or a blob, in your database across those. So you have now detailed document, lots of large documents with text content. Now we're going into those documents and across those documents to pose questions using vector search. The vector search is a semantic search. It's not like a pattern. It's not like string matching. It's not using a like. It's doing semantic search across those documents using a language model. So basically, it's complementary to the Select AI. I would expect customers with documentation, large documents, to be using both in an application. Here's a pipeline using vector search. You vectorize the user question. You find related data. You compare the vector of the question with the vectors in the text chunks of the documents. You augment the prompt, and then you send that to the language model. This is a more detailed breakdown of that pipeline as implemented in a PL/SQL function. It introduces some new components. I expose the configuration in a table so end users can change parameters if they wish. I retrieve the previous question and a response to give it context. This is not the chat history. This is providing vector search with the previous question to allow that continuity. We create the vector prompt using a Cohere model. We perform a semantic search across document chunks. Technically, in my procedure, I append all those chunks together. I append prompt instructions to the prompt. I use a Cohere rerank function to rank the relevancy of the chunks. That's a different model. It's all in the pipeline. That wasn't in the previous slide. And then finally, I send the request that includes the prompt instructions, the chunks, and the chat history back to the request, into the request, and it comes, and then I update the conversation in the prompts for that conversational history. Let's see how that works. So backing up a step, all this is in the Git. Don't have to write it down. You do need ACLs. I need an ACL for our own OCI service. I need an ACL for the re-ranked Cohere model. There's the getting the ACLs and the privileges right there. Our Git repository has all the setup steps. I'm not going to go through them in detail. You're going to create a user. You're going to grant rights to that user. We do have a grant to the job. Why? What has job got to do with vector? Well, I have in the application we created, it allows you to upload documents. They could be large. It takes maybe a minute or two to document to text, text to chunks, chunks to vectors. It takes a few minutes. So I kick off a job and it all does it in the background so the user doesn't have to sit there and wait. We use a couple of credentials. We have database objects, documents, document vectors, conversations. We track conversations. All of this can be done concurrently. And you can have multiple users with their own conversations happening concurrently. We have prompt documents, and which are the chunks, prompt instructions, AI configuration. If I go into the documents itself, these are the ones we're going to be working with. It is legislative documents from Texas. I uploaded the Constitution. You can see the size of it. Some of these are large. And for fun, I decided I took a 3 hour webcast, really interesting, personal interest on nutrition. And I thought it was 3 hours. Oh my gosh, how do I boil that down? So I used our speech service to convert that YouTube video, extract the text out of it. It's amazing. You should check it out. Not covering it today. We use it on our team to extract all the content out into text so we can analyze it. And then I uploaded it here for analysis, and I'm going to just show you that briefly at the very end. So then we have the document vector as well, which is the chunks. Of course, we vectorize all that. And so for every document, you've got multiple document chunks. Let's go back to the flow here. We have a trigger. So if you upload a document if you upload a document, it creates the vectors, updates the document size, create text from PDF, and populates a CLOB column. Why am I doing that? I am doing that because if I want to issue a question to the entire document, I'm using vectors. If I use vector search, it's only doing the top 10, 5, whatever chunks. And if I say summarize it all, the challenge is, well, all it's going to be able to summarize is the chunks that get returned. So I wanted an option to bypass vector search and just search the whole document, send the whole thing there and ask question. So I populate the CLOB column to be able to do that. We have a couple of sequences, a package for adding conversations, prompts. I have a rebuild vectors if you want to rebuild your vectors for whatever reason. The functions are where the meat of the logic is in. That's where the pipelines are. 2 of them there. I have also views using the Apex app. Everything that's sent to the language and is returned from the language is all JSON. It's all JSON. So we have JSON functions to flatten those. So when you're in Apex, it all just looks like relational data. Now, I'm going to bypass the bulk load. That's all the same as the August presentation. I mentioned the chat history package. It's here. Just compile it. It's used in the Apex app. It also can be used. It also is used on issuing SQL, but you just compile it. It's got the functions, the package body. You don't need to, we won't go through all that in detail today. And then we get into this chat function. I did a diagram of the pipeline here. Very briefly, going to go through it. Set the conversation. If a conversation doesn't exist, create a new one. This now, unlike my first version, it now has one function, supports both SQL and Apex. So it'll transparently create the conversation on either of those. Retrieve the configuration, retrieve the previous question and answer. That's net new as well. For vector search, previous question and answer, vectorize the user question, retrieve chunks based on vector distance, add the prompt instructions, blah, blah, blah. Ranking, this is all net new as well. We're doing a re-rank on the document chunks, which was not done on the last one. And finally, we pass the response, the request to the language model, the prompt instructions, the prompt, all previous prompts and questions. It's a running chat history is running chat. And then the document chunks to consider. We send that, and then we get the response back, and we save it. I save it back. So you got all the gory detail. And let's see this in action. Here it is here. I'm going to now execute this. I'm asking the language model a question. It's running off. It's running that function. It's doing a pipeline. There it is there. There it is there. There's the answer. a little hard to see it there. So what I'm going to do, one other thing I forgot to tell you, I added domains. We actually have domain search now. You can actually specify a domain here. Let's go back here, go back to here and log into the vector one. And let's have a look and see what this looks like. We're going to run it. And we had a conversation running in SQL Developer, but this is a new conversation. This is a conversation that gets created when you first log into Apex. I'm going to select a domain now. The domain is a default domain. I'm going to ask all those legislative documents questions. Let me do that. And I'm going to submit that question to the language model. Now we're going to be able to see it in Apex a lot easier than SQL. We've got a conversation ID here. We've got a prompt ID. There's the answer to the question. There's the references, the documents. We've got documents that were sent to Cohere re-ranking, the document name, an index on that, the document ID, the score, the relevancy of the text chunks that went into answering that question. You might say, well, the user shouldn't look at this. That's true. Probably wouldn't have the user look at this, but when you're looking and analyzing the data as a developer, really helpful to see what's going on under the covers. We also have citations added now. All the text chunks and snippets out of the text chunks and the positions of those text chunks in the citation start and end points. Super handy. Now let's do something a little bit different. I'm going to select the domain as the Constitution, and I'm going to say, rise this document. Now, what is it summarizing? Is it summarizing the whole document? No, it's summarizing the text chunks because we're still in vector search, remember? So we've got 5 code snippets. It's going to take the 5 code snippets and the most relevant ones out of that, and it's going to try and summarize the entire Constitution in there. And it's done that looking at the code snippets here, and you can see that it's probably struggling a little bit because we are doing vector search. We are looking for sort of needles in a haystack, but I built into the application, which also includes, by the way, adding documents, listing, viewing. I've got a new function here, which is like, I want to do a deep dive on the document itself. Constitution's pretty darn big. And so I'm going to say, summarize this docket, summarize this document. And let's issue that, and let's just see what comes back out of that. I'll show you the function. It's going to load the entire clob in and send that to the language model, and it'll give me a summary of everything that's in the Constitution, which is, many, many, many pages long. And now it's not doing vector search. I know the presentation is on vector search, but I wanted to do this because I found out that certain kinds of questions probably were better suited to bypassing vector and going straight to the entire document. Now, this is the answer from the search on that document is now gives you a much better, this is the one that came from vector search. This is the one that came back when I said, hey, I want to summarize a particular document in detail. So let's have a look and see. Well, and there's add documents as well. I won't go into all of this. This will be provided as an export of the Apex app, AI configuration, prompt instructions, conversation history, conversation detail, searching all across all of that is all covered in this application. I wanted to focus on vector search. Let's go back to here. Let's just kind of go back to I wanted to show you the JSON as well. If I follow this follow-up question, are there any financial implications if it as in the previous question, which is this here, this is where chat history comes into play. And there it is there. This is the chat history. My first question is, what is your broadband infrastructure fund outlined? That was my first. There's the answer. Here's my follow-up question. Are there any financial implications if it is passed? And it knows, it being the previous question. Yes, there are financial implications if this is passed, and it goes on to explain that. So I'll go back into a little bit. The reason I want to just touch on the code here is because it is so different from the original vector search function. A couple of things to bear in mind, because I kind of cracked my head on this, and thanks, Steve, for giving me a heads up on how to solve this problem. These documents are large, and I was blowing up on the varchar 32K limit. It kind of blew up. Varchar instruction limit was where I was running into problems. So what you end up doing is you load the entire document into a clob, and the rest of it is similar. We have prompt conversation history, latest chat and prompt sessions, retrieved configuration, but you now need to form the JSON yourself. Unlike the above function, we use a JSON object function. So you form this yourself, then you retrieve the document, and then you stitch them together. The first part, the second part, or the clob, and then the closing, and then you issue that. This JSON differs between models. Heads up, this is for the Metalama model. The JSON requests are a little different for Cohere models. Just a heads up on that. And so then you send that. And here, the last thing I want to my parting comments on this was, again, a sort of fun fact is I have this 3-hour, super interesting, highly technical nutrition webinar. I don't know who makes 3-hour YouTube videos. I guess these guys did. And I used the summary feature, but I also said, hey, nutrition document, prepare a typical menu for the day based on the following nutritional guidelines, which are in that 3-hour thing, which we use speech to convert. A minimum of 160 grams of protein. So this thing actually does the math on that. It gives me breakfast, snack, lunch, dinner, etc., summarizing and adding up everything to saying, oh, this is 190. I can't eat that much. Trust me, I can't eat that much. But the point being is you can do some really interesting analysis of your text using Select AI and all your other data using Select AI and using these language models. Super interesting. We're doing lots of interesting code innovates with that. So with that, I'm going to turn it over to Steve, and he's going to, if you don't like all this code, Steve's going to show you services that generate a lot of this for you at the expense of control. I'll stop sharing, Steve.
Yeah, what I want to do now, so just as a reminder, Derek just demonstrated Select AI natural language to SQL. And what that is basically taking natural language, converting it to SQL statements, and then running the query. And then the second part was leveraging 23AI vector search to store documents, vectorize them, and then do vector queries against them. What I want to cover now is a Select AI feature or functionality within Select AI, but it's called Select AI with RAG. And the great thing about it is it's a combination of Select AI and vector search. It allows you to query your data stored in your database or in object storage. And the nice thing is this last bullet point. It literally automates almost the entire process that Derek just demonstrated when you do DBMS Cloud Vector natively. And so what are the key benefits of Select AI? It allows you to, again, ask questions about your data using natural language. It allows you to use LLMs to help you get better results. But the simplicity is the most, I think the key benefit to that is, and you'll see this in a minute, Select AI with RAG literally will read your data from object storage. It will chunk your data into text. It'll embed the data into vectors, and it'll store that in a vector table / column with just a few simple statements. And so what does that look like? This is a graph representation of Select AI with RAG on the setup side, on the back end of it when you want to create your vector store using Select AI. So what happens is all your data is stored in object storage. So you take your text files, you upload them to a bucket, and you then log into your autonomous database. And you'll see this in a minute. And don't worry, we have Git repositories that walk you through all the setup. Uh, there, the autonomous database will read that data out of object storage. It'll chunk the data, send the chunks to the embedding model that you define in a profile, which I'll show you in a minute. Return that embedding, and then store that chunks embedding in a table, which is a vector column. And it also stores some other metadata on each file and object storage. And then from a user perspective, when a user is interacting with Select AI, they'll ask this question very similarly to what Derek demonstrated earlier. We'll create a profile, we'll enable the profile, and then we'll ask a question. And in the database will take that question that you typed out in natural language. It'll send it to an embedding model. It'll vectorize that question, send it back to the database, and then the database runs what's called a vector similarity search or a vector search. It'll compare the question you asked with all the other vectors to find the top similar vectors that are stored in your vector store. Typically, we return 5. It'll then take those results from the vector query. It'll take the text from that along with your question, all in readable text. It'll send it to an LLM, and then the LLM will clean it up and give you a proper response as a result. And so the nice thing is it handles a lot of that for you. And so here is creating a Select AI RAG profile. It looks very similar to a natural language to SQL profile, other than you don't see any tables or columns because we're not working with tables and column metadata. And here you'll see with the profile, obviously a profile name. Select AI is very flexible and dynamic. You can have different providers along with OCI. You can use Cohere, Metalama, other third-party providers. But this example is leveraging the OCI Gen AI service. And so our provider is OCI. There's a credential. That credential allows the profile to access the OCI Gen AI services. And then there's a vector index name. And then here's where we start to see a difference. This profile defines what model do I want to use for my embeddings, meaning I have a piece of text, I need to convert it to vectors. So you can define the embedding model that you want to use. And then you also want to define, or you can define what chat model or LLM you want to use that will take the results and give you an answer. And so this is where you tell Select AI what Gen AI models you want to use. The second part of Select AI with RAG is creating the vector index. And this is really where all the work is done. So now that we have our profile created, we create our vector index, and we use the DBMS Cloud AI create vector index function. And here you specify the same index name that you specified in the profile. But here's where you tell it where the documents are that you want to chunk and vectorize. And you also tell Select AI where you want to store that data. And so again, we're using Oracle as the database provider, meaning once our data is chunked and vectorized, it's going to be stored in an Oracle table. We give it the vector table name that we want to store it in. We also tell it the location. Now, location attribute is going to point to a bucket in OCI. That bucket is going to store X number of files in there. You also need to give it a credential to access the bucket. And then if you're familiar with doing vector chunking and so forth, you can give it some other parameters around the overlap of the chunks, the size of the chunks that you wanted to do, the size of the dimensions when it actually does the embedding, the vector distance calculation. You want to use cosine. There's other options available as well. And then a refresh rate. Now, this is important because you have an object storage bucket, it contains documents, and you might add more documents to that bucket. Well, the nice thing is with Select AI RAG, it creates an autonomous pipeline behind the scene, and based on that refresh rate, it'll read for new objects and then chunk them, embed them, and store them in your vector store, so Select AI can access them. And so once you execute this statement, it literally reads object storage, chunks the documents, vectorizes them, and stores them all into. And then once that's all done, from an end user perspective, you just execute DBMS Cloud set profile similar to what Derek did, where you have to tell it, well, what profile am I using for Select AI RAG? And then you can see you use the narrate function or action to say Select AI, narrate, and then you ask your question, and then it will go out, perform the vector search, send it to the LLM, and give you a final response. And then also, if you're curious, there's other actions you can run. The narrate will give you what you're asking for, but if you want to see, well, what vectors did it find? The top 5 vectors did it find? You can use the Select AI run SQL, and then it'll give you the actual chunks of data or the vectors that it used to come up with an answer. And so at this point, I'm going to jump over to SQL Developer. I'm using SQL Developer, but you can use VS Code like Derek did. And so when you execute Select AI RAG, let me jump over here real quick as well. And so everyone was asking about, will this code be available? It's all available here. The links will be sent out to you along with the recording post-event. And this will show you all the setups that you need to do to set up Select AI RAG. And as you can see here, it covers creating the users, the credentials, or the access that's required to the packages. If you're using third-party LLMs, you need to set up an ACL. Select AI RAG requires credentials to access the services. And then this is creating the profile. And again, this is all covered in this document. If you want to see existing profiles, you can see it. And then you create the vector index. And if you notice, I also include links to the actual Oracle documentation. So I try to include all the attributes and values in the examples, but if you want to read up on them, you can actually click on the documentation links themselves and see it. So this is creating the vector index. And then this is how you interact with it using the profile. So this is all done in the Git repository. So once I run the DBMS Cloud Vector Index and the index is created, what you'll see is, because I told it to use a certain name like Texas House Bill vectors, it'll create a table. And in that table will contain all the data that was in my object storage bucket. And it'll be chunked based on the attributes that I told it to. It'll be chunked, and then it'll be embedded. And when that DBMS create vector index is executed, as I mentioned earlier, there's an autonomous pipeline that's kicked off. And you'll see tables that'll start to show up, and you'll see the status of that pipeline be executed. And if you look at the data in that table, and now this is from some time ago, but it's still very relevant, you can see that it picked up 21 documents from object storage. These are the documents very similar to what Derek used. It shows that they completed successfully in the time that it was done, and it shows that how much it was the size of each file. So the key is when you kick the DBMS vector or DBMS create vector index, you can go over to this table and you can actually see the status has changed for these files as they're being processed by Select AI RAG. And so once they're processed and completed, you'll see that the vector table will get created, the text will be chunked. There's metadata on the information on each table or each file. The vector index for each chunk is there. Also, the vector index themselves are created. You'll see them there as well. And at this point, a user can interact with this data. So if you jump over to, I'm just using SQL Developer Client, but you can do this in Apex, pretty much anywhere that you can call a database. Uh, and so again, I need to set a profile as well. So we're going to execute the profile. Now, if you want to see what profile is set, you can execute this statement, and it shows that the profile I just enabled is ready. And now we're going to ask our first question. We're going to say, what is the role of the Senate? And we're going to use the narrate action. And as you can see, select AI RAG went out with the question, what is the role of the Senate? They embedded the question, went and issued a vector similarity search query, and came back with information on what the role of the Senate is. As you can see, it also provided in the response what document it found in object storage. You can see that it's using the constitution.txt inside my bucket. Now, if you want to see what vector records were returned from that question, you can run what's called the select AI run SQL, and this will show you the top 5, in this case, uh, chunks or similarity results when asking your question. As you can see, it brings back the data. It brings back the text format of it. It tells you what document it found it in. It also provides you with the URL to the object storage object. And then lastly, it gives you a score, a vector search score. And lastly, if you're interested in seeing, well, what SQL statement was actually run to bring back those 5 records, you can run what's called the explain SQL action. And it will bring back the actual SQL statement that was executed to bring back those 5 records. Now, as a reminder, Select AI RAG, the benefits of it is that it's a complete end-to-end solution for reading documents from object storage, chunking them, embedding them, storing them in a table, and then querying those vector store with Select AI SQL statements. Now, the next thing I'm going to move on to is OCI Gen AI Agents. Now, this is a somewhat new offering. Again, it's another option which allows you to ask natural language questions against your data. The way OCI Gen AI agents work is they leverage what's called knowledge bases. Currently, there are 3 supported knowledge bases in Gen AI agents. The first is object storage, which leverages OCI OpenSearch in the background. The second one is OCI OpenSearch, but bring your own, meaning if you already have an OCI OpenSearch configured, set up, and information stored in it, you can leverage the OCI Gen AI agent service to query that existing OpenSearch. And the third one that we support is another bring your own. If you have an existing Oracle AI vector search in Oracle Database 23 AI, very similar to what Derek showed in his earlier section on vector search. You can also use OCI Gen AI agents to connect or wire up to that native vector search database and ask questions about it. Now, the OCI Gen AI agents are available in 3 regions currently. You can see them here. They're available in Frankfurt, London, and Chicago. I'll be using the Chicago region today. And so what OCI Gen AI Agent Servants allows you to do is once your knowledge base is created, you'll create what's called an agent, and that agent will have an endpoint that's also connected to a knowledge base. And I'll show this to you live here in a moment in the OCI console. But what it allows you to do is it allows you to connect with your knowledge bases that you may have already in OCI search or 23 AI vector search. Again, you can ask natural language questions. Uh, the agent responds very similarly to Select AI RAG, where it gives you a natural response. It also will reference the sources or what they call citations. It also keeps context. So once you start a session in an OCI Gen AI agent, The session is current, and you can ask up follow-up questions uh, on results that you were given earlier. Uh, Meaning that there's chat history that's maintained for that session and is used when newer questions are asked. So at this point, I'm going to move over to the OCI console. And before I do that, actually, I'd like to walk through. This is the Git repository associated with the OCI Gen AI agent service for this webinar. This one covers specifically setting up a native vector search knowledge base and then connecting that through the OCI Gen AI agent. There's a lot of steps. Again, throughout each task, I link out to the real documentation if you want to read that as well. But we'll go through this real quickly. Uh, Very similar to the other services we showed earlier, you have to create policies in order to access the agents. Once that's available, then for the 23 AI vector search, bring your own knowledge base. It is expecting that you already have 23 AI installed, database, vector store created. All the documents are chunked and stored and vectorized and available for you to connect that knowledge base to it. There's a lot of requirements around 23i vector database, requirements for an OCI Gen AI knowledge base, and I kind of go through them here at high level. Uh, it's expecting existing 23i vector database in the same region. I'm using Chicago. The database has to be currently in a private subnet. You have to add some ingress rules to the subnet associated with that private database. You have to create some vault secrets, which stores the passwords for the database. You leverage a database tools connection uh, through a private endpoint to actually connect the knowledge base to the 23i vector store. And then you have to develop what's called a database function. And that database function gets executed when you interact with the knowledge base through an agent endpoint. And I'll show you all this here in a minute. And so this is the function that you write. It's very basic. You're essentially taking the question that you ask in the OCI Gen AI agent service. You embed that using your embedding model that you prefer. In our case, we're using OCI Gen AI. And then you run a SQL statement, which takes the embedded question and does a similarity search, similar to Select AI RAG and the vector search that Derek showed earlier. And then it returns back the top 5 records along with the actual text itself and a vector distance score. And again, this Git repository walks through creating all the steps. In a lot of cases, this is more of a guide where it just shows you these are the steps, these are the notable steps, and then a link to the documentation corresponding to the setup. I also show some examples of of how you chat with it using the chat console, which I'm going to show live here in a minute. And then if you use the Python SDK, I provide some sample code where you can establish a session and then ask questions to the agent itself, and then it'll bring back the response. And then for those who like to do everything within the database, I provide a simple database function which uses a DBMS Cloud send request to interact with the OCI Gen AI agent service. And this is a sample PLSQL function which allows you to do that. So now I'm going to move over to the OCI console. And if you remember earlier, the OCI Gen AI agent's only available in 3 regions right now. So be sure that you're on one of the regions that support it. I'm leveraging Chicago. If you move over and look at, if you think of the requirements you need, I'm going to show you the 2 knowledge bases I have set up. So the first one, which is much simpler, is the object storage one, which uses OCI OpenSearch. I have a bucket with PDFs stored in it. These PDFs look very similar to the ones that Derek used and I used in the Select AI RAG portion earlier. I have the Texas House bills along with the Constitution stored in PDFs. Uh, and so then if you move over to the OCI Gen AI agent service, this is the overview. It kind of gives you a little wizard or order of steps that you need to set up your knowledge base, your agent, and your endpoint. Uh, so first thing you need to do is create a knowledge base. If you go over to the knowledge bases here, you will see I have two of them that are active. One is the Texas House bills PDFs that are stored in the bucket, and the other one is the Vector 23 AI knowledge base. That's to bring your own vector store that's already set up in autonomous database. So if you click on, I'm not going to execute this real time, but I'll show you what the screen looks like. If you clicked on create knowledge base, enter a name, you have a choice here, object storage, OCI open search, and then vector search. If you picked object storage, then you specify the data source. And here you can pick your bucket. You can specify you want to select all in your bucket. You can use prefixes if you have uh, several files that you don't want processed, but you have them sorted by prefix slash folder. And then once the knowledge base is created, uh, you'll go over to the you'll see the knowledge bases here, the data sources here. When you create a knowledge base, you have the choice of saying, I want to ingest the data right away. I want to kick off an ingestion job. And so if you click on the actual knowledge base data source, you can click the ingestion job here. And then once it executes, there's a status log that you can click on and you can see what was ingested. And you can see here that the job started. They found 21 PDFs objects. It processed all 21. These are files that were created in OpenSearch, and it mentions the bucket that was leveraged. So at this point, I have a knowledge base created based off of an object storage bucket. Those files were ingested by OCI OpenSearch, and now I can create a agent against those. And I have an existing agent, but I'll show you what that looks like. So if you click Create Agent, you can define a name. You can also describe like a welcome message. If you have specific instructions that you want to pass in, you can define those there as well. Here you want to select the knowledge base that you want. Currently, I believe it's a one-to-one agent to knowledge base. So you can pick whichever one you want. And then not only do you have to have an agent, but you also have an endpoint that you can interact with. So if you want to create that automatically, you can check that as well. But I already have one created. So if you click over to agents, pick the existing agent that I have, you can see that it has a knowledge base associated with it. That's the object storage one I just created. It has an endpoint. Um, if you edit the agent, this is where you can decide. So you can have one agent and then you could switch between the knowledge bases. So you can't have them both enabled, but you can choose which knowledge base you want that agent to interact with. Currently, this one's going to interact with the object storage knowledge base that I just showed. So if we cancel out of there, at this point, the agent and the endpoint is set up. And so if you click the launch chat, this brings up an opportunity. If you have more than one agent, more than one endpoint, you can change them here. But this is on my agent and endpoint. And at this point, I can ask questions very similar to what I did in Select AI RAG. If I say, what is the role of the Senate? I click submit. Now, what that's going to do is that's going to take my question. It's going to go out with that question and search my object storage knowledge base, which is based off of OCI OpenSearch. And it's going to come back with an answer. This is the site. This is the text that it came up with, and very similar to the similarity search in Select AI RAG and in vector search that Derek showed earlier. You can view the citations, and here it shows that okay, these are the citations. It brings back 5 of them. And it shows you what document it found them in. It shows you a path to object storage. It also provides you with the object storage knowledge base. It provides you with the page numbers of where it actually took this text from. Um, and then, and this is very similar for each of the citations. The nice thing is you could click on this open a new link, and it actually opens up the entire document in another tab here. And then you can read down through the Constitution. You can also, if you decide you're like, oh, I want to download that document, you can click the download button and it'll download the Constitution to your local machine. So that's how you interact with a knowledge base using the OCI Gen AI agent chat playground. Now, if you want to switch over, I'm going to switch over to the other agent, and this is a 23. Well, actually, not agent, but knowledge base. If we switch over to the 23i, bring your own vector database. Um, and what I did for that is I already had an autonomous database set up. And I know this is a lot of moving parts. That's why we documented this all in Git and referenced the actual documentation throughout. So I have an autonomous database. It's running in the same region that the OCI Gen AI agent service is running in. You can tell by the network that I'm running in private endpoint. Um, and so once that database is created, my vector store is created inside of the private database. Then you have to create a data tools connection. So if you go over to database tools connections, you'll see that I have a connection to the 23 AI database. And if you look at this connection, you can see I have username. The password itself is being stored in what is called a vault. So that's a secret in a vault. So that's where the vault service comes into play, so that the password is encrypted and not available. Uh, uh, the instructions walk you through how to set all this up. You have to use the connection string from the autonomous database wallet, make some minor changes to it. Again, that's all called out in the Git repository. So once this connection is established, you can actually interact with your database similarly to SQL Developer Web, SQL Developer uh, Local Client, or Derek was using VS Code earlier. So this is going to look very similar. So I'm connected to the private database. You can see that I have legislation data in here. I have legislation vector. So all those documents that are stored in an object storage is very similar. We read them uh, into the database, stored them in the database, use 23 AI vector native functions to chunk them, vectorize them, and store them in the database, which now allows us to query those. But the one thing that you have to also do that I talked about earlier is you have to create that function. So this is the function that is used to actually connect up the knowledge base in the OCI Gen AI agent service with the autonomous database vector store. So if you look at this function, it's going to look very similar to the one that is in the Git repo, but essentially it has some code that embeds the question that you ask. Then it does the similarity search to return the document text, the name of the document, the object storage URL. I hard coded it in this case because we didn't store it natively in the vector database. It also returns a score, and so once the tools connection is created, once the function is created and tested, now we're ready to create a knowledge base in OCI Gen AI agents. So very similar to the object storage one. I'll go through the screens, but I won't create it live. If I pick Oracle AI vector search, this is now expecting me to bring my own 23AI database with a vector search content stored in it already. So now it's asking me, do you have a tools connection to connect to it? Yes, that's the one I just showed you. You can click test here to see that it's successful. And now this is where you can pick your function, the function that I showed just a minute ago. Based on your rights, you're going to see a lot more functions than what I saw in the SQL worksheet. But here's my function that I tested have working out. And at this point, you click create, and the knowledge base gets created, and then it allows you to interact with it using an agent. And so if I switch over to my agent, I'm going to pick the agent, and then I'm going to switch it here real quick. It only takes a moment. I'm going to switch it over to the 23i vector search, bring your own vector store. I'm going to click Save Changes. The agent has to go through a slight update in order to make sure that the agent and endpoint is going to interact with the knowledge base I wanted to now. So it's going to update here just for a moment. Now you see it's active. So it's ready to go. I can click Launch. I'm still using the same agent, same endpoint, but now it's pointing at a different object story or a different knowledge base. And again, I can ask the same question: what is the role of the Senate and it's going to go out, and this time it's going to take my question. It's going to use the function that I wrote that I showed you a few minutes ago. It's going to vectorize that function into an embedding. It's then going to execute a select statement to do a vector similarity search against the vectors I have stored in my database and bring back those top 5 records. And very similarly to the object storage knowledge base, I have the option to see view citations. Now this one's a little bit different because I'm not using OCI Open Search. It doesn't give me a page number or the ability to download it because all that information is literally coming from the 23i autonomous database that has the vector store already created in it. I believe there's support or there's plans for an enhancement in the future to include a page number, but at this point, the native vector functions do not allow you to capture the page number for the chunks. But you can see that it's very similar. It gives you the citations, which document it found. It gives you a link to the document that contains the text in these chunks, and then because that document was, I believe, 21 in my database, it shows you that number as well. So just to recap, this is OCI Gen AI Agent Service, which supports 3 knowledge bases. 2 are bring your own, which means you already have most of the content already set up. You just have to wire the agent knowledge base to it. And that's OCI Open Search, bring your own, and 23i Vector Search Database, bring your own. And then the native object storage one is you can create on the fly using buckets in object storage, where it reads the documents, ingests them into OCI Open Search, and shows you the results. So that concludes my part of the presentation. Thank you very much for listening. I'm now going to hand it over to Pete Madura, who's going to walk through one of the offerings or programs that we offer in the Code Innovate team, and it's the Code Innovate program itself. Thank you.
Thank you, guys. Amazing session out there. And I just want to take a few minutes of your time to tell you all about the Code Innovate program. Simply put, it's enablement and training program for new and existing Oracle customers supported by a team of deep dive engineers. So, what does this program offer? Well, we start by reviewing your strategic use cases, which typically require technology to solve. We then pair that use case up with our engineers who have deep experience developing on the required services and potentially with similar use cases. And with our guidance, we help your organization deliver a first-pass prototype of the desired solution. So let's take a closer look at the framework of the program. These events, is what we call them, are typically 1 week long and they're virtual. We typically facilitate these through Zoom, and you and your teams are driving all the development. In a sense, we are just over your shoulder telling you how to build out the solution. And a single event runs for 4 hours a day for a total of 20 hours for a week. And lastly, there is no cost associated with this program. So here are the basic requirements. First, we look for a suitable use case. And what does that really mean? Two things. One, can we support the service or services that are needed to fulfill the use case? And two, can we get it done in one of these week-long events? Or you can think about it, can we get it done in that 20-hour sprint, as we call it? Obviously, the time commitment is 20 hours. So that's really what we're asking for from customers. We're asking for their time. And in these events, we like to get 4 more developers and or analysts from your side. Not everyone has to have hands on keyboard. Some could be just watching, but we do like to have as many participants as possible. And leading up to one of these, we ask for about a 3-week lead time. And then we talk a little bit about that lead time. Once we've got a use case, then we all work together to find a suitable date that will work for everyone. And that's sometimes the hardest thing here because it is a big chunk of time. And then once we have a date leading up to the date, we'll have a few check-ins. One, we will help set up your environment. That could mean provisioning services, adding users, connecting to data sources, stuff like that. And then prior to the event, we will also offer some structured learning or some training demos. Now, there are no pre-requirements of learning or knowledge on any of our services. But we do like to give a little training right before the event to expose some users to it. So maybe they're not seeing it for the first time during the event week. And then we jump right into the event week. We have heads down. We're just working all week. And at the end of the week, we strive to have that kind of minimum viable product that we discussed going into the event. At the top of the screen right now, you see we've got the email address if you're looking to contact us and you're interested in hosting one of these. You can also put your name and email in the chat if you would like us to reach out to you. And if you're already an existing Oracle customer and working with an account executive, you can reach out to them that you're interested in this, and they know how to find us. And we do this for many different services. Some of the popular ones are Oracle Apex. We're doing a lot more with our Gen AI and AI services. Very similar. Actually, we've done exact events that Steve and Derek kind of showed today. We also have other popular services like OIC or Oracle Integration Cloud, VBCS, Oracle Analytics Cloud. So we do support a lot of the OCI PaaS services. So hopefully you got a lot of great knowledge out of today's session. The recording will be made available to everyone in a few days on demand. All that code will be available also with the posting. And with that, we thank you everyone for your time, and I'll pass it back to you, Aaron.
Thank you so much, Pete. Folks, we have some upcoming developer coaching webinars. If you want to go ahead and scan that QR code or visit that URL, you can see what's coming down the pike. And we really want to hear from you. What did you enjoy about this webinar? Derek put a lot of work into that, obviously, so be nice. Just kidding. But we do want to hear what you have to say and what you're looking forward to. Are there areas that you want to learn more from Oracle developers about? AI, database, Java, you name it. We want to hear from you. And with that, folks, we're going to say thank you. The recording for this webinar is going to be up on the Oracle Developers YouTube channel. And I think for a webinar like this, with so much information, you're going to want to revisit that. So we will see you there. And thank you for joining us. Have a great rest of your week, folks. Thanks again.